Hello, ladies and gentlemen. I hope everyone is doing well today. We are back with another Chemquest, this one called Lewis Dot Structures. So right up top, we have some information on valence electrons. So this paragraph, very, very important. As you can see, I have a lot of stuff highlighted. So, the first thing, so we know that valence electrons, those are the electrons that are in the highest energy level. Valence electrons are also located the furthest away from the nucleus. Next, valence electrons, these are the most important electrons because they are the electrons that are involved in chemical reactions and chemical bonding. So down here, we just covered electron configurations in the last Chemquest. So right here I have an electron configuration for thallium, number 81, if anyone wants to check it out on the periodic table. So, right down here, we have our electron configuration. But what I wanted to focus on is what I have highlighted. So I want to focus on the 6s and the 6p. The reason why is because these are the valence electrons. These are the electrons that are in the highest energy level, the outermost. So in case anyone forgets, I have some arrows to help us. So remember, the number that comes in front of the sublevel, that is the energy level. Then the letter, that's the sublevel. And then the exponent, the superscript, that's the number of electrons. So we see here that we have 2 in the 6s, 1 in the 6p. So that gives us a total of 3 valence electrons. So down below, we are going to draw some electron configurations and then determine valence electrons. So the first one we're going to do is oxygen. So we can come over here, look up oxygen on our periodic table. It's right there. Oxygen atomic number is 8. So that means we have 8 electrons to work with. Remember, this is your list of increasing energy levels and sublevels. So we always start with the 1s. So we would write 1s. Remember, s orbitals can hold 2 electrons, so we'd write a 2. Then we can cancel across out our 8, subtract, and go to 6. We have 6 electrons left. After 1s comes 2s. So we do 2s2. Because remember, s orbitals can hold 2 electrons. Whoops, so that means we subtract 2. So then we have 4. After 2s, we see it comes 2p. So we write 2p. Remember, p's can hold 6, but we only have 4 left. So we write a 4. So, you guys can do the same thing for sulfur. You can find sulfur on your periodic table right here. So that has an atomic number of 16. So draw your electron configuration for sulfur. So next, I'm going to help you answer question 2. So how many valence electrons does oxygen have? So remember, valence electrons, you can see it underlined still, they're in the highest energy level. So what's the highest energy level here? We have a 1 and a 2. So we know it's 2. So we can add up the electrons that we find in 2s and 2p. So we would do 2 plus 4. Gives us a total of 6 electrons. So next, I would like you to do the same thing for sulfur. How many valence electrons does sulfur have? Use the electron configuration to help you. And then lastly, question 4. Question 4 wants you to do it for selenium. Selenium's atomic number is 34. So that means that you have 34 electrons to put into your electron configuration. And you should have 6 valence electrons. So hopefully you can find that you get that. Yeah, so then the next section we have some Bohr diagrams. So we are going to start, we're going to review Bohr diagrams quick, and then we're going to start relating our Bohr diagrams to our Lewis dot structures. So the Bohr diagrams that I've given you, so if you look at your periodic table, you'll notice that all of these, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine, the Bohr diagrams that I give you, these are all row 2. Remember, we call rows periods. These are the row 2 on our periodic table. Oh, wrong page. Question 5. So, question 5. In each of the Bohr diagrams in figure 1, the first energy level has only 2 electrons. So that's what we can see right here. The first energy level is the one closest to the nucleus. All of them have 2 electrons, not valence electrons, valence surrounding outer. So to help you answer this, think back to what sublevel exists in the first energy level. How many orbitals exist in that sublevel? And then how many electrons can fit into any orbital? So use that to help you. Look back to an electron's address. Question 6. Question 6 is another one where an electron's address will help you. This time you need to remember how to calculate how many electrons the second energy level has, and then how many the third can have. So next we are going to draw some Bohr diagrams for some different elements. These are the Bohr diagrams that we are going to compare to some electron diagrams down below in the next section. I am going to help you draw boron. So remember guys, in the nucleus we're going to put our protons and our neutrons. So we can look here. We see that the atomic number is 5. So that means we have 5 protons. And then we can subtract. Remember, the sign of the neutrons is the mass number, so round it to the nearest whole number. So 11 minus the number of protons, 5. So that means we would have 6 neutrons. So now we draw a Bohr diagram. Remember, your protons equal your electrons, so we are going to have 5 electrons to fill in. So we put 2 on the inner shell, and then we would have 5, so we would subtract 2. We'd have 3, so we have 3 left to put in. 1, 2, 3. So that's your Bohr diagram for boron. You guys can go through and do the same thing now for nitrogen and fluorine. So next, down below again. So down below again, we're going to have some electron dot diagrams. This time, or sorry, not this time, but they are the same electron dot diagrams as the Bohr diagrams that you found in figure 1. They're the same elements. It's still row or period 2 on our periodic table. One thing worth noting, guys, is the position of the dots is important when we're drawing these later. So what you'll notice is the first dot goes on the right. Then when we have 2 dots, we put one on the right, one on the top. Then 3 dots, one on the right, one on the top, one on the left. 4 dots, one on the right, one on the top, one on the left, one on the bottom. And then we repeat. We add a second one to the left, then we would add a second one to the top, a third one to the left, and then a fourth, and then the last one, a second one on the bottom. So we can make a little thing to help us remember this. So if we had element X in the center, and we assumed that it had a full shell of electrons, the number correlates to where the dot would be if you had that many electrons. So we would put 1 right there, 2 on the top, 3 on the left, 4 on the bottom, and then we repeat. 5 goes on the right, 6 goes on the top, 7 on the bottom, and then the 8th one on the bottom. So this will be more important when we are going forward and we are drawing them. So, question 8. So question 8, what relationship exists between an atom's valence electrons and the number of dots in the Lewis structure of the atom? So we can use the one example of boron that I drew for you on top. So if we were to look at the the Bohr diagram for boron, we would notice that it has 3 valence electrons because those are the electrons that are in the highest energy level. If we were to check out boron's electron dot diagram, we notice that it has 3 dots around it. So what you see here is that that the number of dots in the Lewis structure, that equals the number of valence electrons that we have in our Bohr diagrams. So we see that the number of dots in a Lewis structure equals the number of valence electrons. So number 9. Number 9 is asking you to compare nitrogen's Lewis dot structure. Lewis structure right up here, electron dot, which has 5 dots around it, 5 electrons, to nitrogen's Bohr diagram, which after you drew up here you realize has 7. So compare the pictures. What's the difference? What information are you missing in the Lewis structure that the Bohr diagrams contain? Next, I don't know where I put it. The next page. So number 10. So we can remember in questions 1 through 4 that oxygen, sulfur, and selenium all had the same number of valence electrons. It's worth noting, guys, that oxygen, sulfur, and selenium, they're all in the same column, the same group in our periodic table. So question 10 is asking us to think about tellurium. So Te. Te is found in our periodic table right under selenium, right in the same row. So what you guys need to know here is that tellurium also has 6 valence electrons, and it's because they're in the same column. Every element, every atom that's in the same column on your periodic table has the same number of valence electrons. So that's what we can write. Atoms in the same column contain the same number of valence electrons. So next what we can compare is figure 2 and figure 3. Figure 2 and figure 3 are found right here. It wants us to compare boron and aluminum. So we see that boron and aluminum, we see that they're in the same column on our periodic table. We also notice that they have the same number of dots. So question 11, it wants us to draw the Lewis structure for gallium. Gallium as the element Ga. So we know gallium is going to have 3 valence electrons because boron has 3 valence electrons, aluminum has 3 valence electrons, and gallium. Every atom, every element in the same column has the same number of valence electrons. So then watch. This is where this X thing that I drew becomes important when we're filling our dots in. We know we have 3 dots to work with. The first dot goes on the right, the second dot goes on the top, and the third dot goes on the left. So that would become 1, 2, 3. That, oops, sorry, I was a little low right there. And then, so that is our Lewis structure for gallium. So, what I would like you guys to do now you guys need to draw the Lewis structures for sulfur and selenium. Remember, guys, sulfur and selenium, they have 6 valence electrons. Everything in this column has 6 valence electrons. Remember, we already figured that out. So draw some Lewis structures that have 6 valence electrons. Question 13. Question 13, now you need to fill in the words similar or different. So use the trend that we've been talking about in 10, 11, and 12 to help you answer 13. Oh, remember, when you're thinking about 14, guys, when you're thinking about 14, sodium and lithium, why do you think they have the same Lewis structure? Use your periodic to help. What do you notice? What do you notice about the column that they're in? Next, question 15. So question 15, it's much easier to draw Lewis structures than it is on Bohr diagrams. But Bohr diagrams, because they're a little bit harder to draw, they give us a little bit more information. So what I want you guys to do, compare the Lewis structures you drew in 7. You drew it for boron, nitrogen, and fluorine, so also nitrogen and fluorine. Compare. What do you notice? What's different about the Bohr diagrams than the Lewis structures? What information is lost when we go from Bohr to Lewis? It's also Lewis structures, you hear me? They're also listed as electron dot diagrams. We also call them Lewis structures. So next, question 16. Question 16, now we're going to start drawing some Lewis structures. This is where we're going to start putting it all together. One of the things that we learned that can be super helpful is that every column has the same number of valence electrons. So what we can do, we know that figure 2 right here, figure 2 shows us the number of valence electrons. It shows us the number of valence electrons for everything in that column. It shows it for lithium, beryllium, all the way to neon. So we can label our periodic table. We know that lithium has 1 valence electron. Beryllium has 2 valence electrons. Boron is going to have 3 valence electrons. Oh, my cat's coming to say hi. There she goes. So then we can finish. Boron has 3. Carbon, count the dots, 4. Nitrogen has 5. Oxygen has 6. Fluorine has 7. And then neon has 8. So everything in all of these columns have the same number of valence electrons. We can also label them valence electrons. This is something you should label on your periodic table. Remember, guys, I told you throughout the year that you will have different things you can label on your periodic table, and then we're going to make them a resource that we'll be able to use on our tests and quizzes as long as you don't add anything extra. This is one of the things you can add and will be super helpful. So watch. This is how we can use what we just added to our periodic table to help us answer question 16. So we need to find 16. 16 is asking us to draw the Lewis structure for germanium. So we find germanium on our periodic table. Germanium is right here, number 32. So we look and we see what column it's in. Everything in this column has 4 valence electrons. So now we draw the Lewis structure. Remember, we write the symbol, so Ge. Then we now need to add 4 dots around it. Remember, when we are adding our dots, oh, of course my paper fell off the table. Remember, when we're adding the dots, we use this little X symbol right here. The first dot goes on the right, the second dot on the top, third on the left, fourth on the bottom. So that's what we would do. 1, 2, 3, 4. So use your periodic table and use this little X diagram over here in the electron dots to help you draw the Lewis structures for 16. Question 17. Question 17 is now just telling me how many valence electrons each atom has. So use your periodic table to help you do that. So we can do 17A together. We're finding bromine. So if you looked at your periodic table, you'd find bromine over here, number 35. Bromine is in column 17. We look up at the top of our periodic table. Everything in column 17 has 7 valence electrons. Well, that takes us to the end of the Chemquest. Remember, guys, if you have any questions, please make sure you circle them, write down your questions, so when you come to class, you get credit and I can help you quickly and easily. Like always, I will end these with a joke. What would bears be without bees? They'd be ears. I hope everyone has a wonderful day. I'll see you soon. Bye.